Hello, hello.
Test. Good.
Hello, everyone. Welcome. We're going to be talking about how to think in Inertia and Rails today. So every good meeting has an agenda. I'm a manager now. I wear my manager hat, so got to have an agenda. Here's what we're going to do today. So I'm going to give a quick introduction to who we are and also what Inertia is. And that is going to culminate in some principles that we think will help us think in Inertia and help us navigate Inertia apps in general. Out of curiosity, how many of you have some hands-on experience with Inertia, either hobby or professionally or whatever? What do we got, about half? Cool. Great. Okay, so then we're going to run through two demos. And the first one is really going to speak to the people with their hands down. And we're going to build a small application from scratch. We'll get to see the really cool DevX that's available in Inertia Rails from that. And then we're going to hop into an existing application that we have queued up. We'll use that as a playground to add some more advanced and interesting features. And then we'll wrap up with some time for questions. So if you run into something that's confusing or you want to talk about something, get ready to ask during the question and answer session. Okay, so who are we? Why should you trust us about Inertia at all? Well, we are the three core maintainers of the Inertia Rails, Inertia adapter, or the adapter for Ruby on Rails for Inertia.js. We've got Svyatoslav. Svat there, you want to wave? He is a back-end engineer at Evil Martians, and he loves coffee. That's very important to know about him. He is well caffeinated, barely slept last night, so we're hoping he'll stay awake. Next to him is Brandon Shar. Brandon is a staff software engineer at EasyCater. He actually hates coffee, curiously, but he does love his dog, so he is capable of that human emotion. And then there's me. I'm Brian Knoles. I'm the CTO at Bellawatt. Bellawatt's a small software company working with energy companies. Brandon and I actually wrote the first version of Inertia Rails back when he worked with us at Bellawatt in 2019. I am the great uniter, and so I love both my dog and my coffee. So if we sum up here,
the only two human qualities Brian is looking for: dog and coffee.
The second column here is probably the most relevant for our talk today. But if you see, I think pretty trustworthy sort of slide overall. Should be able to trust us. Okay, so what is Inertia? This will be sort of a recap for some of you, maybe new for others. Inertia is two things. So there is a core JavaScript library that runs on your client-side code, and then there is a adapter on your server. It should be working with a MVC sort of monolith type of thing. We're going to talk about the Ruby on Rails adapter. It's worth noting that there's actually quite a few adapters out there. There is a Laravel adapter. Inertia actually came out of the Laravel community. Brandon actually wrote an adapter for Django. There's one for Elixir Phoenix, and a few others out there. So it's quite a versatile sort of technology. And it is not a framework. So it builds itself as a protocol, not a framework. We'll see what that means as we run through some of the demos here. But basically, it's going to handle a lot of the communication between our front end and our back end and not try to get in the way of either one. A really good analogy for this is TurboLinks. I'm not sure if anyone is still aware of TurboLinks. TurboLinks was the inspiration for Jonathan Reineck, the author of Inertia.js, as he built this out. And for me, this is a little bit of a stretch, but I think something like Haml or Slim, if you've used any of those sort of ERB replacements, it's kind of similar. An Inertia application will end up having a page structure that's kind of similar to a vanilla Rails application, but with just a different templating library. Cool. So we mentioned it's a protocol. What does that mean in practice? Here's a fairly simplified diagram, and we'll revisit this diagram a couple times through the talk here and kind of add some more detail to it. But this is sort of the basics. So when you make a request to an Inertia application, Ruby on Rails is going to send you back a full HTML page. That page will have a single div in it. That div will be full of JSON data. On the client, Inertia is going to pull that JSON data out of the div, render a React tree or a Vue tree or a Svelte tree. And then from there, your users will be interacting with the application by sending more requests to your Rails server. Rails is going to return, our Inertia renderer is going to return a JSON from those requests. And on the client side, Inertia is going to swap out the new data into our component tree and re-render itself. This, if you know what TurboLinks is, this is very, very similar to the idea there. So taking that together, I think that Inertia can be thought of kind of like a friendly glue that is bringing something like Rails and React together, allowing them to each play to their respective strengths. And where you'll really see this kind of come together is what you get to leave behind. So there's a whole list of bullet points there. You'll see some of that as we go through the examples, but you don't need something like a GraphQL API. Auth will work without JWTs. You don't need the fancy or complicated client-side state management. And then asset versioning and client-side routing are also sort of taken care of for you. So quickly, the history behind Inertia Rails. Inertia.js, which we mentioned a few times, was first launched in 2019 out of the Laravel community. At that time, Brandon noticed that this was solving a problem that we were having at work at Bellawatt, which was trying to get React and Rails to play nicely together. And so in a hackathon, we just spun up kind of the first version of this. And then 2020 to 2024, we used it internally for a lot of stuff at Bellawatt. And there was a small community that was kind of forming around the Inertia Rails library. I had some good contributions from the community, but things really started to take off last year. Early in the year, when our friends at Evil Martians took notice, threw some of their development weight behind it, threw some marketing muscle on it. So you've really seen it start to take off. On the JS side, Laravel now maintains the JS package, and they have resources that they're putting behind it. So there's a lot of new features that are coming out that we're trying to keep up with. But I think the real takeaway I want us to get from this is that this is not really a new technology. This has actually been around for a while. We've been using it in production for years now, and it's not going away. There's support and attention for it in the MindSphere. Okay, so before we talk about why you might want to choose Inertia, maybe let's talk about why you might want something else. There are, of course, other options for building a front end with Ruby on Rails. Probably the most common way to put a Rails and a React app together in Rails is to use something like a JSON API or GraphQL API. Hotwire, of course, is the default stack in Rails. That is a different option you could choose. And then there's a lot of stuff floating around the internet. There's Ember, there's Alpine, jQuery, all kinds of stuff that's still in service. So I think a couple ways you might want to choose one of those. If you have like a very microservice-heavy API architecture that your team is happy with, and that's really what you want to work against. Inertia is going to be a tough fit. Inertia really wants you to be an MVC, or a monolith, I'm sorry. And if you wanted a single cross-platform code base, we don't yet have any sort of native application. Stay tuned, maybe Friday we'll see if we can work on that a little bit. But that could be a reason to choose something else. And then maybe you just really like Hotwire. That's fine. I think we should use tools that our team likes and that we feel productive in. Now, obviously, we are big fans of Inertia. We use it a lot. And so why do we choose it? And I think the number one thing, the real use case, is that you want those nice constraints of the MVC style monolith, but you want to use something like React as your view layer. We think that Inertia is really the cleanest way to get that sort of experience. And then perhaps you like TypeScript on your front end. Perhaps that's something that your team likes. Maybe you want access to the pool of talent that is in the NPM ecosystem. Maybe you want some of the great UI libraries that are available there. And then the inverse of our previous slide, maybe you just really like React. I just kind of like JSX as a templating library. And so I enjoy using Inertia and React. So the promise we get from Inertia and Inertia Rails is that Rails should feel familiar to us when we're in the Rails side of an Inertia application. It should look like Rails that we're used to, and then React is going to feel lighter. And I have a little asterisk here because we're going to be talking through React. I'm going to say React a lot. We're going to say React Vue and Svelte are also supported by Inertia.js, so if those are your tool of choice, just mentally switch those out as I talk through here. Okay, so this is a big promise. Can we actually fulfill it? Let's take a look. Here is a very quick example of a controller, a couple controllers. On the left here, we're rendering JSON to presumably, over an API, presumably, to a React component. And on the right side, this is what it looks like to render the same thing in Inertia. So this feels like we're fulfilling the promise. But what do you think, Pam? And confirmed, it's not quite the same picture, but it's pretty close. This does look familiar, and this is a representative sort of example. But where you really see the benefit here is on the client side. On the left here, to get this data from our controller into a React template, we got all this local state, we've got a use effect, we have this loading spinner that we have to spin up. On the right side, this is really what Inertia will look like. It's just a simple template. Okay, so thinking in Inertia. I'm going to propose these principles, and maybe they won't click or make sense quite yet. We're going to refer back to them as we run through the demos here. The first one, just use HTTP. So we're going to see things like using links, using server requests to mutate data. This should feel kind of like you're using a Rails app from 2010 before rich JavaScript was really a thing. The second thing, let Rails drive. So we want to pull as much of the complexity out of our front end and put it in Rails where it sort of naturally lives. So our server is going to manage our state. Databases are really, really good at updating things. Instead of client-side routing, we're going to define our routes in Rails, things like this. And the downstream consequence of this is that React is going to act just like a view layer. It's not quite read-only, like you will want to have some local state, but you'll have a pretty close experience to the one-way data flow principle, which is what React was kind of built with. It really shines when you use it that way. Should see fewer use effects and just a little scattering of local state just for UI elements. And the last one, the page is the contract. So if you're not familiar with Inertia, page is a concept. It's the way that Inertia splits up sort of your application. And as long as you try to stay within that bound, then you'll have a good time with Inertia. And if you kind of squint, a page in Inertia kind of looks like a view model. So that's something to maybe bookmark and think about as we're running through this. Okay, so enough talking. Let's get into writing some code. Now we have two demos. I'm going to pass the microphone, well, not pass the microphone because we all have them. The Brandon's going to take over and narrate while Svyat runs through setting up a new app. This is something we'll probably just watch. The next application that we'll have, you'll be able to see the code and run it if you want. You don't have to. We'll show everything we're doing. You can just follow along if that's easier for you. But yeah, guys, go ahead and take it away.
Awesome. And as Brian said, you do not have to follow this along if you want to. One of the big value props, and I think one of the big things that led to that big jump in 2024 when Svat and the Evil Martians team got involved was the creation of these generators. Like, testing an Inertia app and seeing if it's for you is really easy. It has never been easier to fire this up. We were actually just talking before this. I have fired up an Inertia app just because I wanted to test React concepts before. It is that easy to get it going. Oh, am I good now? Excellent, thank you. Yeah, we're going to start over from the beginning. Awesome, so we're going to kick this off just straight up. We are starting so far at the beginning, we're literally going to run Rails new here. And Svat's going to take you through the generators, and then I will jump back in once those are up and running, and we'll look at what was created. Inertia is so easy to set up, we up the difficulty for live coding.
So we created a new application. We skipped the JavaScript part because we will use Vite instead of Rails defaults. We believe Vite is a better solution, but it's like up to you. You can use whatever you want. But yeah, we will install Vite with Rails, with Inertia generator. Then we will use TypeScript because I love TypeScript. I don't care. And use React. Also, Tailwind is there by default, so let's use it as well. And that's basically it. So now we can run bin setup. And open the app. So we have an inertia example prepared for us, and it just works. Here it is.
We are up and running. We now have a fully set up Inertia app. So let's jump into it and actually see what the installer created. Obviously, that mimicked kind of the typical Rails installer. But we created a couple components in here, and most of what we're going to look at is not going to be surprising. As Brian said as we looked at this, what are the Inertia standards? Inertia deliberately doesn't do a lot. You want Rails to keep being Rails. We want React to keep being React. So one of the first things we can take a look at is what we created, for example, in routes. Can everybody, size looks good? The back can see it. The front is probably going to have one or more code examples burned into your retina. Let's hop into the routes. Just so we can see and take a look at, we really are just looking at completely generic Rails on the back end. And we're going to see that up until we get into the controller, where Brian already showed the example. You're going to see something that looks exactly like rendering JSON. So we just have a standard route to the Inertia example controller. Nothing new there, nothing unique. Let's hop into the controller. Controller looks exactly like Brian's static example. We are rendering. This looks just like the familiar Rails render syntax. The only difference is we're rendering Inertia. If you've used Inertia in the past, this is a relatively new syntax where you no longer need to specify a component name. What this is going to handle is it's going to exactly the same way that Rails would resolve to your ERB files. This one is going to look for the Inertia example controller, and it's going to look for an index component, TSX, because we chose TypeScript. And then what do we have here? We have a React component. The React component accepts a single prop, which is named. That was exactly what was passed down by the backend. And it renders some React. So in order to really understand what Inertia is doing here, we need some more components. Oh yeah, we can see that we used params to pass this in. But Inertia really shines, like, let's see what happens when we have more components, when we have routing, when we're truly getting the single page app feel. So what Svat is going to do is he's going to fire up our scaffolds, and these will also look pretty familiar. They piggyback off of kind of how the Rails scaffolds have already worked. And we're going to get a number of different front ends set up here. And pages, as Brian said, pages is effectively how you need to shift the view layer. That's really all Inertia changes. The models, Rails models, controllers, Rails controllers, the views, instead of being an ERB file, they're now going to be React components. There we go. So we'll just walk through creating a post or two here.
Why did you have to restart?
Because we're live coding in a workshop. This is how we can create a post. The big thing to notice is we have a single page app. We are navigating around. It looks pretty good. Back to posts. Awesome. So what happened? What is this doing? Where does Inertia actually come into play? So the first place we'll jump in is let's take a look at the index component. So one of the things that we want to make sure to call out here is, once again, calling back to Brian's slides, React is normal React. Rails is normal Rails, so where does inertia actually come into play? Where do we have to think about inertia? And it's very few places, but one of them is this component called inertia link. So we can see that instead of using an href, we are actually using a link component from the inertia library. What that's doing is it's just rendering an anchor tag under the hood. That's an important thing to know here is you're still getting normal links, a normal anchor tag. If you want to open it in a new tab, copy it, use it without JavaScript, it still functions. But when you're coming out of an inertia component, it's going to render a little differently. When we hit the inertia renderer, as Brian showed in the first diagram we had there, there's two different ways you render. If you're coming from a generic HTTP request, it is going to return an ERB file. It's going to render HTML. It's going to hydrate your initial React component. But if you come from an inertia component, it's going to be a completely different request entirely. It's going to be an XHR request that is going to go back. It's going to return JSON, and the inertia front end is going to handle hydrating and swapping out the component for you. Now, swapping out the component is actually simplifying what's happening, really. It is actually using the browser history API. You are getting real navigation. You can use back and forward, and that is how we actually simulate the true single-page app feel. Once you're in an inertia app, the page is not going to reload again unless you specifically ask it to. We're going to hydrate components, move it into the history API, and navigate around that way. So let's look at a little bit more of a complex example here, and let's see what's happening with this actual form. So if we want to jump into, yeah, we can jump straight into our form component. So the form is rendering an inertia form. This is brand new in the generator as of 90 minutes ago. So if you've installed this earlier, install it again. But inertia form is super powerful. It is as simple as what you're seeing here, where you are literally wrapping standard HTML components in an inertia form.
This is a slow one, okay. So you can notice that we don't use any like fancy hooks here. There is no on change. There's nothing about like React specifics. So it's a that simple form. So you can do whatever you want there. Nested forms, whatever Rails does, you can do that because it's under your control. Inertia under the hood just like fetches all the inputs and passes that to the backend.
So one of the things we're sending through the form props here is where is this data actually going? So we can trace this a little bit, and tracing it is once again going to be not very exciting. We're going to trace it back to a standard Rails route, but we can jump straight to the controller. So if we take a look at our create route, we'll see that this is another nice thing that Inertia handles for you. And the create routes are always cool to look at, I think, because this isn't even like, look, there's barely any inertia. This is, look, there's literally no inertia, except in that one redirect. But in our post save, what is happening here? We're routed in a normal sense. We create an active record model and persist it like we always would. And then once it's successful, we're going to redirect. So we're actually returning a redirect response here, not an inertia response. And that's something that Inertia will handle automatically for you. It knows when a redirect comes down, that it's going to take that redirect, and it's going to immediately make another client-side request to go to wherever the redirect is to. So in this case, it's going to go to the show route. So in the spirit of kind of thinking through how this persistence works, let's talk about what is missing here if this is a real app. I think a really common thing to do here would be some validation. So what is the Inertia way to handle validation? As we keep saying, there is not one. There is a Rails way to do validation, and it's just going to work for free for you with Inertia. So Svat is just going to add in completely standard validation right on the model. And what we'll see is Inertia is going to completely handle this, and it's going to pass this data back down automatically as props for us right into the component. Everything works as you'd expect. No, please do that. That's awesome.
Applause is okay.
Awesome. So continuing to move forward in building an app, you'll notice that as we navigate around, every time the entire page is shifting. Now, if this was a Rails app, you would handle that with an application layout. But obviously with an application layout, it's going to render once. You're going to lose that control you need. So Inertia has a way to handle that as well. And this is one of the few places where we do kind of diverge a little from standard React. Now, obviously, these are React components. So if you wanted to, you could create a layout component and you could just wrap every single one of your React components with it. That would work perfectly fine. But Inertia has a trick to make it a little more powerful for you. And what that's going to allow us to do is if you set this up through Inertia, the layout will actually be persistent across different component rendering. So why does that matter? And this is a set showing this is how you set it up right in your Inertia TSX. And the reason it's setting up this page default layout is kind of a cool little trick. It allows you to override the layout on an individual component the same way you might do that with an individual render route. But why are we doing this instead of just putting it into a React component? It gives us a lot of power. So when you're moving from Inertia component to component, if you've worked in React apps before, you'll know that when a component is destroyed and then re-rendered, you're going to rerun effects. You're going to perhaps lose things like scroll position or local state. This allows the layout to actually be persistent. So if you have something in it like a nav bar, you have some local UI that is you're using as a some sort of UX enhancement that's in local state, this will ensure that your layout persists even as we navigate around. So do we have like any kind of, do we have a hard code in the layout for it? Nice, let's just throw a nice hello SF Ruby. Or just answer me directly. Cool, so we have a layout, we can navigate around, we can see that persist. That obviously is not super useful yet. So what can we make it do? A really, really common thing in Rails apps to handle across every single request, especially when a form is involved, is flash messages. Now, as we saw from the demo Svat is doing live right now, we do have flash messages working, but those flash messages are actually just put on every single component. And that's not really something we want to maintain long term. We would much rather move this to some sort of shared component. So as we move this over, we'll realize, how do we get the flash messages? So because of the way the layout is rendered, you don't have access to props in the traditional, it's being passed through your component. You saw from how we set up the layout, it's wrapped around that. But luckily, Inertia provides a hook called usePage, and it's very similar across Vue or Svelte. And what that lets you do is reach into some of the data that Inertia is sending back on every request. You can get things like the component out of there. If you're trying to render, for example, you want to highlight different routes, you can get the URL. But the most common thing you're going to look for is shared props. This is a super powerful pattern too. If you've worked with React apps that have, for example, like a deep component tree, this is a really nice way to kind of break out of the React hierarchy if you need to in specific places. If it looks and feels a bit like React context, that is very deliberate. It is React context. But the nice thing is it's managed entirely by Inertia. You don't have to think about it. You don't have to wrap your components. You don't have to think about the hierarchy. It is always going to be available on every page in your app. So as we just jumped to here in the Inertia controller, if you're following how this is working, you may have wondered where that flash props even came from. It's not in, if you could flip quickly just over to our post controller, Svat. It's not in any of our returns here. We can see right there, render Inertia, the only prop we're passing is posts. So going back to the base controller we we're just in, this shows you another really cool feature of Inertia Rails. This is a controller level method called Inertia Share. And what this does is anything you add to this is going to be merged on every single one of your responses. So if you have something like flash messages, another really common use case is like a logged in user. Anything that you need on every single request can be shared this way.
One caveat there. This is sharing on every single page because this is in our application, our base controller that we're inheriting from. This is a controller level method, so you can have a share method call on a single controller, and you'll only get the data in that single, or in the pages in that controller.
Yeah, great call out, Brian. Yes, this is, you can have this all the way at the base layer for things like Flash or logged in user. You can have these on individual controllers if you want to have that just on those routes. So another really cool thing here, thanks to the generators we have, is we get a lot of free TypeScript hinting with this. Right in userland, we're automatically going to get a types file that includes the shared props we expect. We get Flash for free because we know that's already set up by the generator, but it's super easy to add anything else that might be coming through there. So before we move on from shared props, let's go back to that inertia controller one more time, because I want to call out a little bit of interesting syntax we used here. So user is just passed as a hash, but Flash, even though it is a hash, is being passed as a lambda. This is a specific optimization that I'm going to talk about a little bit here, but we're going to see real examples of it as we move into our advanced options. But Inertia, the renderer, doesn't care which way you pass props. You can pass the actual prop, you can pass a callable like a lambda. It's going to evaluate all of them before it resolves the page. The big advantage to the lambda, as you might be guessing, is it lets us wait to actually call that code into the last possible minute. And as we're going to see in some of the advanced examples, there are a couple really good reasons you might do that mostly revolve around you might not want to call it on every single render. So we can hop back down to the app. If you want to click around, we'll see that we should have the user moved over there. We should have Flash messages. I'm like setting us up for failure by demonstrating it. Oh, it worked. Okay, great. So the last thing I want to talk about kind of in this basic example is we'll show a little bit of example of how to set this up, but it's versioning. And it's another really, really cool thing that Inertia gives you for free. If you've worked on a React and an API-based React app before, you've almost certainly run into the problem where you need to make a breaking change somewhere. Either you're going to make a breaking change in your React signature, or you're going to pass down different data from your controller. And if you're working with single-page apps like this, a user experience that I really like, that problem is only magnified because now not only do you have a breaking change in two different places, you may have users who haven't refreshed your app in literal weeks. Like they could be working with stale JavaScript. How do you handle that? I have been at companies where we have handled that by forcing all of our changes to be backwards compatible, and then the very scientific method of wait a reasonable amount of time to break the user's experience. The nice thing that Inertia lets us do is it has the concept of versioning built right into it. And all version is a string. This isn't like semantic versioning, though it could be. All it's looking is, does the client match the same version as the server? So every time Inertia sends a response down, the server is going to send its version with that. And then when the client makes a request back, the client is going to pass back the version it believes it's working with. If there's ever a mismatch between them, Inertia is going to handle that. It's going to realize that the two versions don't match. It's going to automatically send down a 409 response. And that's going to tell the Inertia client side, okay, hang on. We can't make a normal request. Let's actually do a hard page reload and completely get fresh JavaScript back. It is a really powerful way, and what is super common is exactly as Svat's showing here, is just have this link somewhere to your deployment. Have this be the Vite Ruby digest. Have this be some sort of commit tag, and you never have to think about versioning at all.
And worth calling out that in the generator, this gets set up for you in or in the install generator in the initializer.
Yep. Did we get the hard refresh? It looks like we did.
I don't think so, but it's a live demo anyway. Just believe us.
We're only going to lie one time, but I'm not going to tell you where it is. So the last thing to mention before we start talking about the examples is kind of take it all at the top. I'm really excited about these generators and about the scaffolding. And the thing that's so exciting about this is the barrier of entry to try Inertia is extremely low. As I mentioned, I have literally done this recently because I've wanted a React app. I wanted to test out some ShadCN components, and it was actually easier for me to spin up an Inertia app than it was for me to figure out, like with Create React App gone, I was like, I don't want a React router app. I just want to try rendering some components. So if we want to, let's flip back over to the slides, and then I'll just show through. So Brian showed a diagram of the Inertia flow. We're going to update that just a couple times, and this is the first time we'll look at a new version of that. Two more up. Two more up. That one, yes. So now that we understand kind of how the protocol is working, we have the initial request. We're already in an Inertia app. The app is going to detect the version mismatch. We send down a 409 response. One of the pieces of data in that is the original URL we were trying to reach. The Inertia client gets that, and it's going to fire off that full page request we mentioned. What does the full page request do? The same thing it did at the very top. It's going to render the Inertia ERB. just as Brian said, it's going to send down a payload, hydrate a div, and that div is going to end up hydrated into the full Inertia app. Everything is back to normal. That's one of the really nice things about Inertia is it truly does not matter if you get back an Inertia response or regular response. You're going to get the same experience either way. The moment Inertia can take over, great. But if it can't, it's just going to keep sending down ERBs and loading them from there. All right, we're going to transition into some advanced demos. A quick round of applause for Svat for handling live coding.
We are going to tempt fate by actually switching presentation computers.
This is true
See
hard mode.
how this works. Brandon, do you want to maybe take some questions while I'm getting set up? Because it'll take a minute or so.
Yeah, absolutely. On the back.
Inertia share directive, you mentioned that you can reuse it in subclasses of your inertia controller.
Yes.
Does that overwrite what was previously put into the original inertia controller, or does it add to that set of data that's been moved?
Yeah, it's a good question. So whenever you do the inertia share, so the question is, it depends, because it is going to merge what you're passing in there. There's a couple different ways to do the syntax. What we just showed there was the typical key value. You can also pass that a hash, and it will merge that it will deep merge what you're passing into it. So if you send it...
You can actually control that. So there is a deep merge versus merge behavior, which is a flag, I guess. I don't remember that, but you can control that.
So yeah, you can build them up over time throughout your app. You can also deliberately or accidentally overwrite them if you have a lower level controller. Yep.
I don't know if you're going to demo this, but what about a data stream?
We will show that in a demo.
Yeah, we have an example of that in the demo. I think one of the things that we'll show is there are places where it is perfectly reasonable to leave inertia and then still get benefit from it. Some of them are, if you want to pull in things, like we're going to show an example that uses action cable. And you'll be able to see kind of clearly where inertia shines, and then where inertia is just like, hey, this is why you still have a Rails and React app here. Yep.
Do you know if there's any idea to integrate something like inertia modal into inertia, not only for modals, or like, I don't know, popover is the other one, but enable to just put a whole piece of the view in a controller, similar to what you would do with just hardwire and turbo.
So the question is, what about extending the inertia? Like, for example, with...
Not only pages, but get a full component to be backed by a controller,
Right.
instead of having one controller for the whole page.
So
Modals is kind of like...
models is just an example, but what about rendering like not models, but components instead of the whole pages? So we are experimenting with that, but it's kind of a hacky thing. If you have time, we can show that. Like you can, for example, use like a cookie store, like we use with errors, for example, for redirects. So you can add data there and redirect back to the previous page, and it will work kind of like that. You will see some examples of that in advanced demos. But yeah, there is also like an extension for modules, which is written by Pascal, who is also in the core of Inertia.js, the JS and Laravel part. So I don't know if he wants to merge that. So, but yeah, what I love about Inertia is that the protocol is so simple. You can kind of play with that and extend it. And we have some tricks in Rails as well by extending the protocol, because you can build upon this. But again, maybe we'll see some of that if we have time.
Yeah, there are a handful of places where we have very deliberately not taken on some features just to keep the API simple. I mean, React has always been a big inspiration for me of how they just keep shipping major versions and it very rarely breaks anything in a downstream user app. And they do that by just not exposing a lot. So I think that, as Seth said, like there's a lot of room in Inertia for contributing projects and things that will be built on top of it. Any other quick questions? Yep.
My current code base has like many different React apps. Is Inertia a good solution for like that more focused state?
Yes, this was almost like a fixed question. I'm like, we planted you. So what Brian will show a little bit leaning towards this, but not specifically. But one of the first places that when he and I started using Inertia on a project is that it is perfectly reasonable to have Inertia live. Like, you can have isolated instances of Inertia in a single app. You can set up Inertia layouts. You can set up multiple Inertia layouts and basically have, like, the way we've seen structured apps before, even whether you're transitioning an app to Inertia or whether you aren't, you just want one part of your app to take advantage of it, you can set up individual controllers and application layouts so that you have one section in your app that when a user navigates to it, they will suddenly be in the Inertia ecosystem. And then it is completely as simple as just don't use the Inertia link for links out of it, just use a regular anchor, and they will immediately exit the Inertia ecosystem when they leave. So you can have like multiple instances of Inertia can play nice in a single app. A single instance of Inertia alongside a Rails app, a Hotwire app, can also work well. Did that answer your question?
Yes, but right now we're like passing state between different apps through like the URL params. I'm wondering if like Inertia could just handle that, but it sounds like yes, it would just be one instance instead of many.
Yes. Yeah, that's one of the big ways of thinking in Inertia, as Ryan kind of talked, is URL params actually work really well with it because it allows the server to drive and send those props down. You no longer have to read them from the front end, and it basically just allows you to remove local state. That was a big unlock for us of thinking about when you're setting up something like a form, for example, and saying, normally in a React app, you might keep that all in local state, local filters. Pushing that all to the URL is actually better for Inertia than anything else because now you can control it in your Rails controllers. It can be handled through routing, and then you just pass down the props that Inertia needs to be aware of. Any other quick questions before we jump into advanced demos? Like we said, we are going to make sure we have a little time at the end for more questions.
One more.
But yeah.
Based on the way that you pass data in to the Inertia app itself, are you still able to do like bundle split if you're trying to separate those two apps?
Yes. Yeah. I think we might get that. Do we get that by default? Is tree shaking enabled?
No. By default, we use like batch or like we load all the components, but you can play with that. So Vite does that for us basically. So and there is I think it's in advanced. Yep, code
Now,
splitting. So
Yeah, we got a page in the docs that kind of runs through this. See if this position works. But yeah, it's mostly just piggybacking off of Vite, but yep, definitely possible.
Cool. Let's jump into some. Brian is gonna bring up. This is like the already cooked. He's pulling it out of the oven just a few seconds later. This is what Svat and I were building.
So this part could be interactive if you want to be. We've got the demo, the code that we're going to be running through at this link here. That QR code should take you there, I hope. I tried it and it worked. And you can pull that down. If you're going to run that locally, you just need to run bin setup, but make sure to do that on the main branch. If you try to do it on one of the feature branches, you're going to run into an error. You can then switch between the feature branches, but we have a last minute change to fix that. So just a quick warning. You don't have to follow along here, but we have a whole list of stuff to go through, and this will help us kind of run through and see the principles that we've been talking about, see some more advanced or more complicated things that we might want to do in an Inertia application. And yeah, I'm going to do a mix of typing and copy pasting here because there's quite a bit of code. So, does anyone need the QR code still up? Can I move off of that? Great. I am going to fire up our brand new, just announced startup. There's still a little room in the round if you're looking for an investment. We are bringing together the two most frivolous spending demographics in the world, coffee lovers and dog lovers. This is pups and pour-overs. And this is the playground we'll be working in today to try to look at some of the fun things in Inertia.
And you thought Brian wasn't going anywhere with those intros.
Yeah.
No.
It's a callback. Great. So at this point, we're just building the pups and pour-overs community. This is basically just a forum. And you can see we've got some categories over here. We have some posts which may have the smell of LLM-generated content. I can't confirm that. but some very, very important things like caffeine and dog safety discussion. Just for the record, please do not give your dog coffee. These are separate pursuits. Cool. So you'll notice when I go into this application, there's no way for me to respond to any of these posts. And so that's because I need to sign up. And so I'm going to do that real quick. Okay, signing in, no one password. And you'll see that I am now signed in, and I can, yeah, it is great with my dog. And we can post messages. Okay, so the first point that we want to go through, and it really piggybacks off of what Brandon was just talking about, is this sign-up process that we just went through was not Inertia. There was no Inertia involved there. That was actually Devise. And so we have an Inertia app that is coexisting very, very easily with Devise. And so I want to show off what that looks like here. It's really, really quite simple. Let's see. In our application controller, we are setting a layout here and choosing a different layout if we're rendering auth zoom. Oh, sorry. Give me a second here. Thank you, Svyat. Is that better? Can everyone see? Yep. Okay. Close that down. So we have two different application layouts, and if we pull up auth, you can see it's very similar to our application layout. We just don't have the Vite application loading in there. And so we have a very easy sort of interplay between Devise and Devise in our Inertia-based application. We've had things like this in production where we have like a customer-facing site with Inertia and a Hotwire-based site for the admins. Actually, the CFP app from Evil Martians has Avo HQ as an admin, Inertia on the front end. So it can play really nicely. It's kind of the rules of thumb here are that you want probably a set of pages. Again, thinking back to our principles, the page is the contract. So you could conceivably have each individual page either be like a Inertia application or a vanilla Rails application. I wouldn't recommend that. You probably want to have big sections to do that, but there are ways to sort of incrementally move towards Inertia if you do something like that. Okay, so we're logged in now, and we want to start adding some features. The first thing we're going to do here is we're going to try to wire up the search because search doesn't do anything at the moment. So I am going to actually code this out. Let's see how this goes. First thing I want to do, I'm going to start in Rails. We're letting Rails drive here. I'm going to create search. I want to create a controller. And this I'm going to paste in so you don't have to watch me type all day. And I'm going to add, you can see that that controller is referencing a scope. So to clean up the controller, we're going to add a search scope. And this isn't doing anything fancy. It's just using light queries on our database. You could use something more advanced in a real application, but this works fine for us. Okay. All right. So we have our server side set up now, and we want to set up our client side. So the first thing I want to do is take a look at where this is defined. That search bar is defined in app layout. .tsx, and I am going to, again, copy paste some code. Need to import our form components. Up here. Cursor knows how to help us. Bum. Okay. And we need a page to go to. So this, again, is going to look fairly similar to what you would do in a regular old Rails app. More copy paste. Oh, we got an error. Say that again? It absolutely should. That's a great call. Pages. Thank you. And there we go. Okay. So now, if we search, we get our search results. And so let's run through real quick what we did here. Again, we went into our routes file. We created a route. Went into created a search controller. This search controller looks almost identical to Rails. We're rendering inertia here instead of rendering to an ERB view or rendering JSON, something like that. We're using a scope from our model, just like in a regular old Rails app. And if we go into our app layout, we have, again, this inertia form component that we saw in the Getting Started demo. We're using the same thing here, just have this single input for a query. And it works. It just works. So it's very similar to the experience you get in regular old Rails. But this is a pretty, not a very dynamic experience. So we can go further. And what if we want something like live search results? Okay, so in this case, what I want to have happen, so the behavior I want to see is that as I type, I get search results. And really important here, we got a bunch of pages. And so I want that to happen on all the pages. And so we're going to reach for inertia share again. Because we want to share data across multiple pages. And so I'm going to create a controller concern to share something across different controllers. Again, this is just sort of Rails patterns in action. I'll paste it and then we'll talk through what it's doing really quick. So we're calling inertia share here, and what we're saying is we want to pass back every place where this concern is available on a controller. We're going to pass back to our page object the prop of search result. If we don't have this parameter, this queue parameter available, then we're just going to return an empty object. And if not, we're going to, this is the same query we had before. And this is the data that we're returning. So we're returning our topics and our query parameter back to the front end. And we're just going to throw this in application controller. If this was something that you only wanted in certain controllers, you could include this in individual controllers, and you'd only get that data in those controllers. Okay, now the fun part.
And you can see too here, like similar to one of the questions we got, there are multiple inertia share calls happening through this. And they just keep layering on what the full inertia share payload is that's going to be merged with the props in the response.
All right, so I added a bunch of code now to our app layout. Oh, one thing I did not mention. So all the things we're going to go through are available as pull requests in this demo application. And so if you want to, I mean, I'm zooming through this. It's hard to see 100 lines of change code. If you want to see what kind of a diff of what I'm doing here, that is available in the repo. Okay, so we made some changes to our app layout. We have now a handler on that input that is just a regular click handler like you would have in any old React application. And when we get a change on that, we're going to debounce a search call. And so every, I think it's like 500 milliseconds, we're going to send a request to the server. And what does this request look like? Okay, this is an inertia feature right here. It's reloading the page, and this is taking advantage of a feature in Inertia called partial reloads. Brandon mentioned this earlier as something that is a good reason to wrap things in lambdas. We'll actually demo that here and show why that is true. And so what this is telling us is I want to grab the same page from that I'm currently on, but I only want to get back the search results out of that. So let's see, I think that's everything. Let me make sure. Yep, that should work. Let's see if we need to save anything. Okay, so now, as I type, you can see that our drop-down is updating and we're getting instant search results. We can click on those and go to the actual thing where we want to look at. Okay, so let's take a look at the request, or the data that's coming back in our network. So we can see what is happening. Let's see. When we request the page. So when we request the full page, we're going to get a bunch of data in here, a lot of topics. But because we have that only key in the request, in the reload, we are only getting back search results. And what's going on behind the scenes here is that the inertia renderer is filtering out any of the keys in our props object, except for the ones that are sort of whitelisted from our only call. And so this is nice. We get less data back, but there is a little bit of a gotcha. And so what I'm going to do here is go to a different page. So we're going to go to my topics. These are the topics that I have commented on. And I'm going to add something to our page. I'm going to say something expensive. And we're just going to simulate some sort of calculation that's long. So we're going to put a sleep call in there of, let's do a second and see if that does it for us. And now when we reload this page, so if we load, let's go to topics, notice how quickly that loads. If we go to my topics, it's now slow because we have this slow call blocking our render. What's surprising here, perhaps, is that now you can see as I'm typing, we get that same delay. And so we don't expect that because we're trying to filter out everything with that only call, but we're seeing the behavior anyways. And so there's a really, really easy fix to make that work. If we just wrap this in a Lambda, let's reload the page. Notice it was slow to reload again. But we're getting faster results. We're getting a little pause because of the debalancing, but we are actually not executing that something expensive call. What's happening is that the renderer now has a chance to actually filter this out before the Lambda calculates.
This is the big advantage, as we mentioned, like to wrapping things in those lambdas, is that Inertia will wait until the absolute last possible moment to evaluate those. So in this case, when that last possible moment is after the only call has already filtered out unnecessary props. So we still got the little bit of a delay on the initial load because that prop had to evaluate, but we don't get it anymore in the only because that prop is being removed from the response before the point that that callable is resolved.
What allows that lazy evaluation? Is it the ERD engine that actually evaluates the lambda that you pass?
No, that's part of the inertia renderer. And the inertia renderer goes through and effectively it builds up a propped hash based on all the different props that can be merged and a number of decisions. We're actually about to talk about another one where this is involved, where it picks which props should be in each response. And then the last thing it does is filters through them. And then anything that is a callable like a lambda, it resolves it at that moment before it's returned.
Is there a way to do that with use inertia instance variables?
Oh, good question. I don't know.
Are you the guy that uses that? Scott said he met someone that uses that feature. Ah, okay. Great.
Now, this is kind of off the top of my head. As
It is possible, yes. You just add the...
if you just loaded a call, like if
Yeah.
your instance variable was a callable, I think that would work.
I think that would work,
Yep,
yeah.
yep.
Cool. So we're going to rotate a little bit here. I'm going to pass the IDE to Brandon here. Before I do that, let's see if I can find it. I need to turn off my Vim key bindings for him.
You didn't have to say that in front of everyone.
Let's see.
Here comes the guy who needs a mouse to use an IDE.
All right, all clear for pretend programmers. I'm just kidding. Cool. Oh, okay. Let me get back. I'm in the extension here. Yeah, go here. This guy. Yep. Awesome. So, as Brian just showed, the way we're evaluating props can have a significant slowdown in this. And in this case, he was able to just ignore that prop. We didn't actually care about that slow loading prop for the response of search. But it's still there on the page load. When he did the refresh, it's still 8 a second. So what are our options when we do run into that? So what I'm going to hop into is I'm going to simulate something very similar in the topics controller. So right now, topics controller. Yeah, there we go. Cool. Oh, you reverse the scroll too. This whole thing is foreign to me. So exactly the same as Ryan did, what we're going to do is add the concept of trending topics. And I'm going to throw in a little bit of UI for this.
It's still Vim. It says normal, I think. No? It's like a normal mode, so you need to reload.
What is it? Oh, I'm okay so far.
Oh, we still have the Vim key bindings.
I could survive here.
You can survive? All right.
How many do you need to help? Cool, so I'm going to hop into the topics table. Can I Command P here? Is that going to blow up everything?
No.
Okay, excellent. Cool. I'm just going to add in, what do I want to add here? In the topic row, we're going to add the concept of a trending topic. It's kind of just a simple idea. It's trending. We'll throw that into our signature. Thank you very much. Import. We should have a trending icon. Perfect. And we'll make this simple. We're just going to throw it right here next to the name if it exists. Is trending. Thank you very much, cursor. And then we just need to render that for the table. So the way we're going to handle this is we're going to pass down trending topics, which is going to be an array of IDs, because this is going to be super simple. Trending topics. And I don't want an array of topic, just give me IDs. Cool. So we should be running here. Oop. I was going to say, what did we blow up? Oops. I want to default that. There we go. Cool. So nothing's showing up. Let's pass those down. Back to the topics controller. And what I want to send is trending topics. Oh God, this is where the Vim key bindings bite me.
What do you need? You want to paste that in? Yeah.
I'll just turn off the, just get me out of this nightmare.
There.
I can click and type.
There you go.
Thank you. Topic, okay, yeah, we still just need render inertia, topic, trending topics, awesome. So, all right. We're just going to make this really simple. We already have topics here. Three, and just give me the ID. Topics. Oh, I'm putting all this in show. That's why it doesn't look right. The joys of live coding. Perfect. Okay, but of course, this is going to be super performant. And the reason I'm going to demo this is almost like one of my pet peeves in live coding, where it's like, look how fast and performant it is. We're looking up 3 items from a SQLite database running. So let's make this slow down. So now we should be able to hop back over here. We'll hop to another page. We'll go to topics. And you're really going to see that slow down already. So you can see we have the loading bar. It is extremely slow. So what are our options here? As we said, we can wrap this in a Lambda, but we already did that, and it's still slow. So why is it still slow? Because we had to resolve it. Like I said, it resolves the last possible minute, but it still had to actually resolve here. So one of the first ways we can look at to fix this is the concept of an optional prop. So if we make this, oh, thank you. So if we make this an optional prop, we're going to get back to our quick rendering. But we're going to get back to our quick rendering at the consequence that it's just not there anymore. So we didn't actually solve anything. So how do we fix that? Well, Brian already showed a pretty clear example of this. What we can do to fix that is we can go into our topics page, which is topics index, and we can actually say, okay, so this rendered. Oh my God. Vim key bindings again.
Let me just, we can actually disable them. We don't have to make you suffer. Restart extensions. All right, there we go.
Freedom. Okay, so we go back into our topics index, and what do we need to do? We need to pull those down. So now we're going to start going into some normal React. Let's do a use effect. It's a use effect that we just want to do on mount. what we want to do is router.visit. We want to visit topics, the same place we came from. And we want to pull in only, but we want to pull in only the trending topics. And you'll notice that we have to write a decent bit of code here to make this work. Great. Oh, thank you. That is absolutely correct. Cool. Let's do some imports. Thank you. Router is correct.
This router visit is the same as router reload since we use the same URL. So as AI says, you can just replace it.
Oh, never sent that down.
Saying reload the current page I'm on, but also include this new route.
Yeah.
Yeah, and router.visit is a programmatic way to do the same thing that, for example, the link component is doing. It's the same underlying mechanism.
There's the topics table. No, that's a number. Why is it not like that? Oh, because that is. Cool. So, this should work with a significant consequence. It's going to keep loading over and over and over. So this is actually an interesting little, this is a nice little trick that Inertia allows us to do. Yeah, no, I exposed your amount of Chrome windows you have running, Brian.
Years
So what we
of
can say
browsing
is-
history in there.
Why is this loading over and over and over? It's loading over and over because it keeps remounting the component. This is a really easy thing to fix. We can just tell it to preserve state. So now, we are up and running. We still have a slow load, but the initial load is extremely quick. We don't have our trending topics coming in, but it's fine. We can see the load. This is when it actually resolves. So that was a bunch of code. And one of the things we kind of promised here is that we wouldn't have to write things like those use effect hooks. So this is a really common use case. I have something I want to load. Maybe it's analytics, maybe it's a dashboard, but something a lot slower. So how can we do this a little bit better? Instead of firing all these, obviously we can improve it a little bit with the reload, but Brian already went through that. How can we get through that? How can we just get rid of all of this entirely? Like, I don't want to think about use effect. I don't want to have to manually call that. It's good to know that we can call that. We've shown things like inertia link. Router is the programmatic way to fire inertia link calls. It's the same thing happening under the hood. All we're doing is we want to make that inertia XHR call. So let's get rid of all of that. I'll just leave the import. But now we're back to that state where it's a slow load, but it's a quick load, but we never actually get it there. So how do we fix that? We fix that with one other prop type. So if we go back to the topics controller, we're using an optional prop. And like I said, an optional prop means do not send this prop unless the client specifically asks for it. Another type of optional prop is something called a deferred prop. So what this deferred prop will do is the same thing. I don't know why it tried to call it a deferred prop. It was wrong about that. So the nice thing about the defer prop is what these do is now we get the same instant page load, but what Inertia is actually going to do is on load, it will see that we have a deferred prop in the request, and it will automatically make that client request behind the scenes without you asking for it and say, give me the rest of the data. So it's only one load. Nothing we had to actually set up here. So yeah, I'm going to clear the network tab. There's our response. Is this visible on the screen?
Yep.
No, I didn't move it up.
Yeah, clears right there.
There we go, cool. Actually, I'm going to leave, I'm going to clear. We're going to go back to topics, and we're going to see two different calls here. One of them that just took 2 seconds to resolve. So the first call, let me drag this up to make sure it's as visible as possible here. So that first call came back with this response, and it included something really interesting. it included a deferred props with a key in it. This tells the Inertia client, hey, we're not done here. We want to immediately make another request for that. And this second request was fired up with that deferred prop, only receiving that. It automatically knows to go back to the exact same URL, resolve the exact same page. And this is a really nice way to set up anytime you have big data that you want to, anytime you have any slow running processes that you want to speed up. And this is a lot more complex if you're doing it with an API. If you were doing this with a conventional API, the first thing we'd have to do is split these endpoints up. And the second thing we'd have to do is set up multiple use effect hooks. We need the first one to get our main piece of data, the second one to get our slower piece of data. With Inertia, it is just such a common pattern that it's completely free.
Yeah. How do these special, so you're showing us how it looks on the server, right? How do these special prop types look on the client? Is it just sort of like internal markup that's added to the ship prop? How does Inertia know that JS has
Yeah, so when we get this first response back, and this is invisible, we're going to distinguish between kind of two different clients here. There is, in this sense, the Inertia client understands it because the payload includes this deferred props key. If I go to a different, page here, like if I just go back to this dogs category, you're not going to see that anymore. It's not going to pass that deferred props. So that's what actually tells the Inertia client when it's returning that response. One of the things happening in the renderer is when it goes through all the props, it sees props that it calls, I believe we call them something under the hood, like not on first load props is what it is under the hood. And it knows all of these props on an initial request need to be filtered out. In the case of a true optional prop, we then do nothing with it. It's up to the user to request it. But a deferred prop is one of a couple special types. Deferred props are interesting, merge props are interesting in that way, where it actually does inform the client. From the perspective of the client, as in you and your React code, it doesn't know anything about it. It is blissfully ignorant to this process. All it knows is that it didn't get the initial variable. It initially got props that didn't include that, and then Inertia automatically merges the props, so it doesn't really even need to know they came in two sections. You're going to get a payload to your React component that includes some props and is missing that, and then the second payload you get is going to be all of the props.
Is there a way to tap into that deferred state, like to know whether it's finished loading or not?
Oh, good question.
You basically will get like undefined in this prop, and then you will get something. But yeah, probably something else is also
maybe one of the callbacks, event callbacks. Yeah, I never thought of that. It's an interesting question.
There is, we didn't show it here because it was such a simple thing to just say like, hey, just check for the presence of this variable. But the Inertia client side actually has a deferred component that you can use straight into the Inertia front-end libraries. And the deferred component basically acts like a nicer wrapper for that. What it is effectively doing, though, is saying, like, don't do anything until this prop shows up. And that's effectively how you'd know it resolved. Like, one of the really nice things, Brian showed this all the way back in his original example, was the example without Inertia had a guard clause. It had an if loading or if not data, show loading. Inertia lets you always remove those because you're 100% guaranteed at the time the JavaScript is rendered, your props are guaranteed to be there, with the exception of if you do something deliberate, like these optional or defer props. So it's effectively, you can reliably, if you have a defer prop like this one of trending topics, you can reliably add a conditional in your React component that says if this is not present, then we know the second request hasn't resolved yet. Like there's only going to be another time this renders, and it's going to be when that second response comes back. And then all the preserved state that I had to do, you get all that for free in this. Inertia knows that if it's making a request to the same component with the same method, that it's going to treat that as a preserved state. Preserved state also includes a preserved scroll. It says basically the user should not know all we're doing is swapping props out in this situation.
VNet goes the component after the first request and then after the second.
Yes. Yeah, as soon as the second request is, it is going to re-render the component, but it does preserve the state of the component. So if you set up, like, the only thing changing is the props, and then now you're just going to React's virtual DOM actually deciding what's going to happen from there. Inertia, to be clear about what I'm saying there, Inertia is not going to swap out the component and replace it with the same component. It is literally going to replace the same replace the props in the existing component. So if you had a user, maybe if that took 10 seconds, and your user is scrolling or they're changing a tab or something you have local state for, that's all going to be preserved when the deferred prop arrives. And that's the same with anything that arrives through that same reload mechanism. The deferred prop just abstracts it away, so you don't have to think about it.
All default props need to be for the same URL, or can it be for different?
In order to get the free mechanism deferred props, it assumes it is the same URL. If you're pulling something down from a different URL, honestly, that's probably a place where you want to leave Inertia's pattern a little bit, because now you're kind of moving into the normal API flow. Like Inertia generally trusts like the React component is the view layer. So the idea of like props going to it is conceptually coupled with what's loading. Now, I don't mean that in the sense of like, don't do that. There might be a perfectly valid reason you want to make a call out to a third-party URL to bring something in. That's one of the things that, I mean, we've said it a few times, but it's worth repeating, is just Inertia is just gluing React and Rails together. If you want to do something in React, like make a third-party API call, by all means do that.
Cool. Back to me for another demo. Let's see if this will stay up. Out of curiosity, how many people are actually in the repo, looking at the code, using it on? Oh wow, everyone. Nice. Okay, worth the effort. That's great. Okay, so we've showed a bunch of examples, and we had initially this protocol diagram. But there was a question earlier from someone, I think it was you, about doing streaming or something else. And what we're talking about with stream, we're not going to show actual streaming responses, but what you're getting at is what if we actually want to leave the Inertia protocol and do something different, and can Inertia help us there? And so the answer is yes, obviously, because I would show it off if it wasn't. So we're going to run through that. And so we're starting to get short on time, as we assumed we would. So I am going to copy paste.
Yeah, we're on copy pasting. Like streaming props are. So we did some experiments actually with true streaming props in Inertia, and the big thing holding it back is actually how fetch works under the hood. The opposite way. Fetch works great with them. Axios does not. And the Inertia protocol right now is built entirely around Axios. There is interest in moving it to fetch, and then we would be able to have true support for potentially for streaming props coming in. But put Vim back on.
I got to. I'm lost without it.
I'm starting to think maybe we shouldn't share a laptop going forward. We should keep each using our own for work. It's an optimization that didn't work out. It's when handling service and events, Axios does not like to keep the long-running connection open. And there is like an Axios. Axios has some improvements to just use fetch under the hood, and I'm not sure. When I was experimenting with it, I could not get Inertia's version of Axios to just implicitly work with it. So what we had to do was kind of set up a different fetch, and then one of the nice things, as you've noticed, like we haven't looked at things like CSRF tokens at all, because that's just all handled through Inertia's Axios. So there's really good reasons to not leave Inertia's Axios as much as you possibly can. But true streaming props, I think it's definitely possible. It's just going to be a matter of like, can we get it into the underlying JavaScript? As Brian mentioned earlier, the Laravel team owns the JavaScript repos, which has actually been a really big boost for us in that having a dedicated team working on them. They've brought probably some of the coolest things they brought recently is like the form components came out of there. Infinite scroll is something we've been working on. And it allows us to really diverge from them on the back end. Like Inertia Rails, if anyone has ever used the Laravel version, Inertia Rails is not a direct translation of it because Rails and Inertia have different conventions, different ways of looking at these things. So it was very much a what features does the front end offer, and then how do we want to expose those to Rails users?
But working with WebSockets is what current demo is about. So
yeah, if you're poking around in the code base, you'll notice we already have a lot of setup for WebSockets. So we have Action Cable set up. There is a channel. It's a blank channel. Let me pull it up. You can actually see right here. There is a channel already, and we have a hook in the front end called use cable. Use cable is not really has nothing to do with Inertia. This is just a React utility that you could use in any React app to connect to a Rails action cable WebSocket. What else do we have in here? We also have a chat message model. So we pre-seeded this, so we didn't have to spend time creating a model. There are messages in the database if you seeded the database there. So we have some of this set up just to kind of get through that. And I have added a couple components. And what else do I need? I need the chat channel, yes. So we're basically going to get an aha moment where, hopefully, we'll see. Don't want to tempt fate. I believe, all right. We need one more thing. We are going to have, again, a controller concern to load some shared data. This is a pattern that we end up using quite a bit. And this concern is going to load paginated records of our chat message history. So there's something like 300 or 400 chat messages in our database. So we don't want to load all this at once. We have pagination set up. This is a new feature as of, I think, 10 days ago in Inertia Rails. It's a infinite scroll, and it's downstream of the work that the JS team has done. So there's out-of-the-box support for Pagey. Is it Pagey or Pagey? I don't actually know. Cool. Kaminari, and there's options to kind of roll your own pagination if you're a Vim user like me and you do everything yourself. And so this should just work.
If you're following the syntax here too, Inertia Rails.scroll looks just like what we did with defer and optional. A scroll prop is another type of prop now. It is another special prop that Inertia knows how to handle uniquely compared to other data.
Okay, so we have, let's keep it here for now. We have an error. Awesome. The page object does not contain a scroll prop named chat messages. This is why we like having him around. There we go. Cursor knows. Okay. Now, when we open this up, look, we get a chat message history. And we just have a single chat room for pups and pour-overs, just one big communal area for us all. No individual rooms or anything. But I'll show how this works, and then we'll kind of look at the code a little bit. As we scroll up here, you're going to see, watch real close. Can you see the cursor or the scroll bar? Yeah, perfect. Okay. When we get sort of close to the top, you're going to see that it jumped back down. And so this is the inertia scroll behavior. Let's actually, where is that? Chat drawer, I believe. That's where that is defined. Thank you, whoever knows the code base better than me. So we're wrapping our chat messages in this infinite scroll component. There's some configuration required here. We have a reverse call to say that we want to scroll upwards and not downwards. There's a buffer so that we don't hit the top of our scroll window before we start fetching. We are preserving the URL, so we're not adding query parameters to the page here. We don't want the chat history to be part of the page URL. But then we just render these this row. This is just markup here. One of the reasons I want to paste all this in, most of this code is just markup and not anything to do with inertia. And then we have a little input here that we're using to submit messages. So let's actually submit a message. Something I think we can all agree on. Luna is the best dog. You see that just sort of worked. And so what's going on here? We're using action cable. What are we doing on the inertia side? Well, let's look up at handle key press. when we hit enter, we are sending the message. And so the message is sending with this onSend method. That is coming out of our use cable hook. So this is nothing to do with inertia. This is just sending a message over WebSocket to our channel. In our channel, we're creating a new message and then just broadcasting that back to anyone who is listening. And then the component will just re-render with that new message. So, okay, this is an inertia talk. Yeah. Well, I'm headed there. Let me see. Okay. Yeah, chat. I'm headed right there, actually. So, so what is going on in inertia here? This is inertia talk. We're talking a lot about Action Cable. This is all of the inertia-specific code required to make this work with WebSockets. So what we're doing here is something called a client-side visit. Client-side visits in Inertia.js they can kind of act like a general-purpose setter for your page object. We think back to our principles that we laid out here. The page is the contract. This is a really, really sort of good example of that, right? Because we're leaving the inertia protocol, we're going outside of inertia, we're using WebSockets just like WebSockets are supposed to function. How do we reintegrate with inertia? Well, we operate on the page. So we merge this new piece of data into the page object, and then it's there for re-rendering the tree, just like, again, one-way data flow from React.
Yeah, this is a really super powerful pattern because exactly as Brian just said, it is that true one-way data flow because we have a single source of truth for all data coming from inertia. If you've used React libraries like Apollo, GraphQL, or TanStack, this is the premise that they're also trying to achieve through pure React code, where we have a single source to cache and validate and pass through your entire app. In our case, it's just a really small single source of truth because we get a fresh world on every page reload.
Yeah, and I'm gonna show an actual conversation going on here because I want to speak to one little thing.
You need me to disagree on the best dog.
Yeah, Molly is the best. We all know that's false, but here we are. And so I don't know if you saw that, caught that, but we're scrolling to the bottom there. So what's going on there? If we scroll back to chat drawer, we have a little piece of code here that is saying if we're within 200 pixels of the bottom of our scroll container, when we get a new message, scroll down. If we're like scrolled up, we don't want you to like zoom you all the way down to the bottom. But notice how this is wired up. This is an effect. It's using a ref, use ref under there as well. We said fewer use effects, not zero use effects, you know, and this is the place where you would want to use something like this. Notice there's no communication with the server. The server doesn't care where you scrolled on the page or anything like that. And so this kind of place where you're sort of adding sugar to the UI or giving the pure UI sort of thing, that's where you would reach for your React hooks in places. But we do see a lot fewer use effects in general. And one thing I have to mention, because Svyat really wants me to mention this, with the client-side visits, you got to be a little careful on the browser history. As Brandon mentioned, when we are navigating around, we're adding stuff to the browser history, so there can be some kind of nuances there. Check your back button behavior and see if it works as you want to. You can replace props or push props, and depending on how you're doing the client-side visit, you might want one or the other.
Yeah, Inertia gives you a lot of tools for how to manage kind of the automatic history state. As Brian mentioned, you can replace or append to it. And then if you are pushing sensitive information to it, obviously we don't have time to go through everything, but one of the different options is you can encrypt browser history. You can link that to the current user. You can also manually clear it if you want to, if we wanted to set that up through here. So you have a lot of options of how you can control what Inertia does with the browser history. Because when you hit that back button, you include the props in it. So you do not necessarily need to make a round trip to the server as you're navigating around the app.
Cool. So we've got about 15 minutes left. I want to give Svyat a chance to show off something that's really cool about integrating stuff from the wider Rails ecosystem into Inertia. And so we're going to pass the. Do you want to do that now? You want to see that now?
Yeah.
Okay. While Svyat is getting ready, we're going to go through our last diagram. We've been modifying this as we go. Oh. This is why we need 3 of us. Am I up?
There we go.
There we go.
Yep. So this is the same diagram we've seen a couple times. It just keeps getting a little more detailed. And it's not that it's getting more complex, it's that it's showing different use cases. So this is now a combination of everything we've seen. This is almost a full end-to-end use case. So let's say we hard refresh the page. That initial HTTP request is going up to the server. The server is responding, as we've already seen, that Inertia ERB, the initial payload that it needs to hydrate the React component. And then if there are deferred props, for example, it's going to automatically send that Inertia request. We have detailed there, X Inertia true. That's pretty much how it knows it's happening. That's a header that's set by the protocol. It returns that JSON payload. As we mentioned, Inertia.js is going to merge those props together with what's already there. And now we have an example. If the user posted a form, send that same Inertia request, redirects happen to the client, payload comes back, and Inertia once again is going to just merge those props, decide if it needs to move the component. And that's really all there is to it. You'll notice none of this is changing. It's just the more interactions we show, it just gets a little taller.
Cool. So we're gonna plug Svyat in for one more demo. We're keeping the guys in the back on their toes here, doing a great job. So one more thing to show, and then we'll open it up for more questions and comments as well, I guess.
If anybody has a quick question while we're switching laptops. Yep.
You transform presumably that scrollable has a set of params and sets. Transform that to be compatible with page under the hood.
Yes, yeah. So I believe there's adapters under the hood for that are putting all of those into, and this is one of the kind of cool places where Rails and Laravel and Django all diverge. There are different standards in each framework for what pagination looks like. Most of the time, because the Laravel team owns downstream, we're adapting a bit in their direction. But yes, that's exactly how it's setting up, is making sure that we adapt, and that's why we didn't show it, but in addition to the Pagi, in addition to the other formats we have, you can roll your own too. If you have your own pagination in your app, you can set up your own adapter to transform that.
So yeah, the final demo for today, presumably, is about adding more TypeScript powerness to that thing. So I'm installing Alba, which is a serializer, Typelizer, which is a kind of plugin that gets all the data from your database and converts, adds that to your serializers and puts out the TypeScript types for you. Alba Inertia is a plugin for Alba to add all those Inertia awesomeness to Alba serializer, like optional, defer, all that stuff. And listen will help us to listen for changes in files. So yes, copy pasting is boring, so let's do this instead. Yeah, and see the the diff later. And there is no PR for that. Sorry, I slept for 3 hours today, and I need those. Anyway, so Alba is a serializer, so it operates in resources. This is our base resource for this application. We are using Typelizer there, Alba Inertia, and we also want to do some niceties like lower camel case because, yeah, React. And instead of writing all the as.json stuff, oops, this is front-end part. Yeah, so instead of writing all the as.json, render, all this stuff, we can just get back to our add variables, like a plain Rails patterns. And now with all this wiring setup, we can use resources that are using kind of like Rails conventions. So categories show resource. And it says like we are rendering one category, and category is rendered by category, handled by category resource, which is nested from category base. So all these niceties, if you want to split stuff, has many topics. So it's a topic resource. We have really tangled application here. It's a startup, so you know how it goes. Anyway, so it's a safe way of passing attributes because with that feature you kind of can. Anyway, so with that setup, we can actually generate types by running our server. You can, by the way, notice that there are no like types mentioned here. Like we have 0 typing information or attributes. Like everything comes from database. So, and we are using this only for one endpoint for now because of a quick demo. But here we have like a bunch of serializers that were generated. I mean, automatically for us. We didn't do anything. We just ran the server and it works. Yeah, like category base. There are unknowns. So why? Because category base is like there is no model with this name. So we can say type-wise from, I guess, and say category, and I missed the button here. Should be working, hopefully. Yeah, now it's hands off the keyboard. Now it's generated. So it listens for file changes and works like on the fly. So, and on the front-end side, we can also like use these types now. So instead of writing all these types by hand manually, we can just import them. And now we know that like in our category, we have like name, ID, topics, whatever. And if we go to like, we have no created at all. No, this is a big problem. So let's add it back. Like created ad or updated ad. I already forgot. But anyway, so now my ID is cache and stuff. So, but it's there. Oh yeah, we use the different casing. So now it's created ad with a proper casing. And that's basically it. So out of the box, you get in not only all the types, you also getting all properties being lazily evaluated for free. So no lambdas, that's just handled for you. Yeah, you getting your controllers from this to this. I will spin up a PR a bit later, so you can play with that, but that's it for this part of the demo. Yeah.
We'll open up for, open it up for questions in a second here. I want to go real quick back to our principles. We're trying to tie them back. I'm not sure we were as consistent as we could have been, but hopefully these make a little more sense now. Just use HTTP forms. We don't need custom sort of form submission in our client-side code. We're going to navigate around using links. We use redirects to get from creation back to our application. Letting Rails drive. I think the typalizer demo is a really, really good example of that, of defining your stuff on the server side and letting the client side read from that. React just being the view layer. we only had one use effect, I think, in our entire application, and we've got 5 or 6 sort of pages that we're running through here, and then the page being the contract. So when we jump outside of Inertia, we can come back in, resynchronize using the page model. So I think that is it. We'll open up for questions. One comment before we go. Can you pull up the docs real quick? So someone mentioned earlier how great the new doc site is. We have Svyat to thank for that about a year ago. We have really good documentation. One page that's on there that maybe people aren't aware of is Awesome Inertia Rails. So if you have something that you've built in Inertia and you're proud of it, or you have a piece of content or a video or something, please submit that here. We'd love to have more stuff on there. And with that, we'll open it up for questions. We have some stickers here also to pass out, a little swag that you can put on your computer. If you stump us with a question, you get 2, so try hard.
You also have to put in a pull request if you stump us with a question.
I saw there's a guide here about doing filtering. I extended that to also include pagination, which is, my question is, do you see doing something similar to the infinite scroll, but for pagination or filtering, something that could be kind of like baked in? Or do you think that using kind of like doing custom hooks or those kind of things, like similar to what's suggested in one of the guides here, is the approach? Just thinking if I should continue to do what I'm doing or just kind of like replace it.
A lot of the way we look at this, and we at least have historically, is trying to make sure we're attaching to like clear Rails conventions. So is there like a place for kind of a built-in filtering concept, maybe like true pagination that isn't infinite scroll? I think the answer to that is probably yes. We'd have to think through of like, how do we make this as generic as possible? Because, and this isn't about Inertia, this is kind of like on any API or open source library you maintain, like the moment we add a feature, we're gonna support it. So we wanna make sure that we're pinning to Rails conventions that are arguably more common than Inertia itself. That's one of the nice things about how Infinite Scroll came together, is that we looked at pagination like Pagi and said, yeah, this is a bigger library than us. This is something we can depend on being supported, and in the community, we're happy to be downstream of this. For individual instances, sometimes it's just easier to go outside of them. But we definitely take a look. Like, I would definitely encourage anyone who's looking at something like that, like open an issue on the repo. We try to respond to those pretty quick, and by we I mean Svat. And we'll take a look at like what the code looks like before and after. And if we can't recommend anything, it's possible like, yeah, maybe this is something we can look at upstreaming into the repo. Maybe this is another place we want to diverge from the Inertia core. Or maybe it's just something we say, we're going to need to see a few more people thumbs up this before we take it on.
At work, our Ruby on Rails app is a financial platform for student-led nonprofits, and one of the biggest pain points right now is our ledger is filled with like N+1s and like a bunch of partials, and like it's just a mess. We're thinking of rewriting it, and we have a lot of stuff in React, just not a big part of the app, just like smaller components here and there. Would it be easy to start using Inertia for like one page or just like a small part of the app and then slowly grow from there?
Yeah, you have some experience with this. I feel like you do. I mentioned that I think in the devise portion. I know there's people that have done something like this. I think you have actual some maybe experience, so Shar could speak to it, but I think the short answer is yes.
It just comes to separating your application in parts. So you will get full reloads when you go from Inertia to your old application, but that's about it. So as Brian showed, you can have like separate layouts. So this layout is for Inertia, that layout is for something different, like device, for example, and use that. So it's easy as it is. And in our new like installation generator, we have like Inertia controller just because of that. So Inertia stuff is all the controllers that are subclass of the Inertia controller. So your application doesn't know, like application controller doesn't know anything about Inertia, and that's deliberately done to make it easier.
Yeah, I keep hammering on the principles because I thought about those for a really long time. The page is the contract is really like the principle to look at here. You're going to want to segment your application by thinking of them by pages. Usually that's going to be corresponding to a route, and you could break those off one at a time or a few at a time or something like that. But if you can break your app into individual pages, you could move those pages into Inertia, I think, in a stepwise manner.
Yeah, that's the nice way to think about it, is because the entry point for every Inertia interaction is just the Rails routes, it has a built-in way to do this effectively. If you're coming from outside of Inertia into a new Inertia route, it's going to follow that original kind of mermaid diagram we had. You're going to load up an ERB, it's going to load it up, you're going to get React right there. Then if the next link you go to is by coincidence also an Inertia route, it's going to follow the Inertia JavaScript flow. It's going to bring back JSON, it's going to have that single page app feel. If the next link you follow is not, we're back to Rails. So you really can just jump in and out. I mean, the effective worst case scenario is a full page reload, but that's almost certainly what you have right now. So it's a nice deprecation, but it's a nice way to handle that kind of gradual transition.
And going back to the question about like multiple applications inside your Inertia application, you can also go to the entry point for some. Oh, it's classes. Okay, finally, it works. So you actually can access the properties in the resolver. So you can like check the URL and define like, okay, is that URL like /dashboard? Okay, we will load this different layout and different like pages from the different like subfolder. So you can also like work with this separation of concerns here. Yeah.
Yep, you can both wrap that in an if statement. You can handle where you're pulling the pages from. Like, these are all defaults, but this file that Svet is showing right now, this is very much a file you own in userland, like after Inertia's been set up. So you can change this file as much as you want to fit your individual. If that ends up being multiple different Inertia apps, multiple layouts, this doesn't enforce any of that. You can change where it's eager loading paths from. You can change how it's identifying the page. You can change what's being rendered.
I was looking at the 2.0 adoption of the deferred, and if a route has multiple defers and you're wrapping different components on the page that only require one defer, is it making a separate request?
There are groups, yes. So you can do groups. So it will, by default, it's a default group. So all the requests, all the attributes will be loaded with one request. But if you want to split them, you can use groups. So it's a like separate attribute to pass to the Inertia thing, and then it will be like separated by like, I don't know, like side or like.
Yep, I didn't call this out. I probably could have, but when we were looking at the request, it said default and then trending topics. And what that came from is when that is fired, as Svet just said, by the default behavior is if you have 10 different deferred props, one request is going to go gather all of them. But if you say like, okay, I've got these 5 that are much slower, you can separate that into 2 different batches and it'll fire it in 2 requests. And then they're all just going to end up merged together at the end of the day. Like, your React components can remain ignorant of that.
Yeah, so then if it was one group and like one was like 2 seconds and one was 5 seconds, both those components in the front end wouldn't load until the 5 seconds.
Correct, yeah. If you had a single group, it's going to be your slowest response is going to dictate that because the response won't come back until they all resolve.
It's the same, it's not multiple requests, it's just one request. So yeah. It's about not request, but like method, right? Yeah.
Mm-hmm. But yeah, different groups will fire in different requests.
Yeah. Another one. Our app has a way for users to opt into like a transparency mode so that their projects are publicly available under like a subset of what they would see. So like receipts and stuff, we don't publish to the public internet. But things like the transaction memos we do. When you return an object with Inertia, are you able to specify like what specific properties are available based on access levels, or is it just all sent over by default?
Yeah, that's a good question. So this is one of the places where what is the Inertia way to do that? there isn't one. It's what is the Rails way to do that? And I think that speaks really well to like what Typalizer can do here of you are returning a JSON payload. So if you are worried about if some users should be able to see some parts of it, this is a really good thing to consider. You can't send, like you want to omit sending that part of the JSON payload. So the way the way we've seen this structured is either use a serializer like this, which is a really nice way to do it. You can wrap the same models in the same, wrap the same models in kind of different levels of exposure for those fields, or just rendering different JSON. But yes, it's a really good call out that Inertia does not have anything out of the box that would say like, hey, they passed a user method, pull out this field. It is very much like what you pass down when you don't specify JSON. If you just throw in a model, it is going to call to JSON on it, like in kind of the classic Rails way. So that's something you need to handle in app before the Inertia renderer takes over.
So this is just an example from the Alba gem. So they have this if statement, so you can pass there whatever you want. So like admin, user, or owner, or whatever.
Cool. Anyone else? One thing to mention before we get out of here, we forgot to do it after the first the first demo, is the starter kit. So Svyat has put together. This is, I think it's on the awesome page if you want to just go there. But there is a starter kit which has even more batteries included than the install generator, ShadCN, and some other niceties. I think you got auth all set up in there as well. And so this is an even faster way to get up and running with an app. I think Brandon mentioned he's played around with this just to play around with ShadCN.
I literally spun this up just to use ShadCN.
Like the fastest way to experiment with this. So worth calling that out. Cool. Thank you, everyone. We're going to leave some of these stickers on the back table here. Grab one if you want. No one stumped us, so only grab one per person. But really appreciate everyone joining.